Well, then without further ado, let's go into tonight's presentation, shall we? Bob and Beth, did you want to introduce Quark?
Howard Cork Hayden is a professor emeritus of physics from the University of Connecticut. A Pueblo native, he graduated from Aurora High School, entered the University of Denver as an engineering major, but soon discovered that he wasn't temperamentally suited to all that reality. He switched to physics and went on to earn his BS, MS, and PhD at DU. On receiving his PhD, he went to the University of Connecticut, where he spent 32 years doing teaching and research. He did accelerator-based atomic physics, including measurements of cross-sections for various processes, measurements of energy loss in atomic collisions, and of lifetimes of excited states, beam foil spectrometry, and ion implantation. He performed a Troughton Noble experiment with 100,000 times as much sensitivity as the original. Then he proved that the experiment was meaningless. Quark has a long-standing interest in energy stemming from before the OPEC oil embargoes of the 70s. Presently, he publishes a monthly newsletter, The Energy Advocate, which in August 2020 began its 25th year of publication. Quark has done 3D photography with X-rays, with an electron microscope, film cameras, digital microscopes, and even, wait for it, a 3D digital camera. He pretends no expertise in mineralogy, geology, rock counting, or proper assignment of names to rocks, specimens, bugs, or flowers. Quark, welcome to the Denver Gem and Mineral Guild, and thank you for being our presenter tonight.
Okay, good. Good. Okay, this is going to be a short PowerPoint. It'll be followed by kind of a show and tell. So I'm going to be talking about 3D microscope with stack focus. Now, you see 3D, you show a picture of the head over there with a couple of eyes, and there's something in the foreground. And your right eye sees that object more or less where the monkey is, and your left eye sees the object more or less where the giraffe is. And that is what enables you to distinguish whether things are in the foreground or the background. And then I have an object sitting over here at the right, and you see that the angle is a whole lot smaller. The angle of view is a whole lot smaller. And because of that, after about 10 meters or 30 feet or so, you don't see 3D anymore. You locate things essentially from size. Now, if you want to take a good 3D picture, you can do it by simply taking a picture at this location and then taking a picture at that location, and then you have to put them together. Now, if you're going to be doing something other than a real foreground and well, wait a second, I got to show something else here. I want to show you how the views differ from the right and left eye. That's a picture of a dessert table at a meeting I went to in Salt Lake City recently. Now, if you look at the middle of the red circle, you'll see that the serving scoop is a lot closer to the post there in the left picture than it is in the right picture. The yellow circle, and in the red circle, you'll notice how the cake seems to have moved to the right if you look at the view from the right eye. And then up here, if you look at the corner of the glass table up there, you can see how far it has moved to that seam in the wood. And so your left eye is seeing something really different from what your right eye is seeing. And that's what it looks like as an anaglyph. You can put your glasses on there and have a look. And the next picture is a colored anaglyph. You can see the it still looks a little bit 3D. And by the way, if you move your head back and forth a little bit, it'll seem to move on you.
Mhm.
Now, this little bizarre thing right in here is something that I just made up that will show up very much in 3D. And it's like they have at the driver's test to see whether you can see 3D. But what you'll notice is that the smiley face on the left is straight above the heart, and on the right, it sits to the left of the heart. Now, just thinking about that without being able to see it, would the heart be closer to you, or would or farther away from the from the smiley face?
Closer.
Closer.
Heart's
Closer.
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 Well, I'll let you just worry about that.
Closer.
And these two arrows that I show right there are the same length, but you'll notice that the heart is much farther from it in the left view than it is in the right view. Okay, now this is the anaglyph, and you can see it, and you can see that the heart is sitting pretty far in the background, and the smiley face is a little bit closer to you.
No, wrong.
Show you a color anaglyph of this thing because it is terrible. Because you just don't get good color anaglyphs when a lot of the stuff is the same color as your glasses. So now we'll be talking about doing some 3D photography of things where all of the 3D that you care about lies within the field of view there, and you have a flat, uninteresting background. Okay, but you take a picture from the left spot, from that place, and from that place, and that's how you get your 3D. Okay, now what kind of displays are there? There's a side-by-side display, and for those of you who once upon a time had a grandmother, this is a picture of an old 3D picture from one of those stereopticons or home stereographs that you see right there. Those are side-by-sides. Those pictures, like the ones I showed before, are not identical. There's a left view and a right view. And then there's the anaglyph technique, which we will discuss a little bit more as we move on. Now, another way to show the 3D is with two side-by-side projectors, one showing the left eye view and one showing the right eye view. But one of these projectors shines through a light that is polarized one direction, and the other one shines through a light that is polarized another direction, sometimes maybe vertical in one direction, horizontal in the other one, sometimes 45 left, sometimes 45 right. But you have some polarized glasses for viewing that. And I think what they use at the IMAX theater at the Museum of Science and Industry, or whatever it is in Denver, they use circularly polarized light that's circularly polarized clockwise and counterclockwise. If you don't know what that is, that's too bad. But it's, anyway, it's a kind of a technical gadget that you just say it works. Okay, now here's how we can see things with side-by-sides. This Holmes viewer located here, you see those little lenses in it? Okay, that little lens right there, that little lens right there. Those lenses are really a combination of two things: a small angle prism and a lens. The small angle prism has the purpose of bending the direction of the light, and the lens has the purpose of focusing the light. And that's what it looks like, and I will show you one after a while. Okay, and if this one I held up against the sunlight, or the sunlight is shining through it, you'll see the sunlight is focused to a spot right here, but that spot is not in the center, it's off to the side. That's the effect of the small angle prism. The effect of the lens is to focus the sunlight. So what the thing does then is to take the center of the picture on the left, and those pictures are, let's see, the width of that whole picture is 7 inches, but there are 3-inch squares, 3-inch square pictures, and so the centers of these two pictures are 3 inches apart, and that small angle prism helps just direct our view out there. Your eyes are relaxed as if you're looking off a great distance. The lens focuses on the picture, and the prism directs the view toward the center of the picture. There's another way to do it, which is to use a sequence of 4 mirrors. And the light from this view right over here comes down here, bounces off this light, off this mirror, bounces off this mirror and goes into the eye. And the opposite sort of thing happens down here with this one. And so you can have your eyes directed to a couple of pictures that are actually fairly far apart. I mean, they can be feet apart sometimes. But anyway, in this case, you have to have your eyes adjusted so you see the pictures clearly, you know, at distance, say on a computer monitor. And then there are these anaglyphs that are usually gray. And the reason for making them gray is that you take the left view and the right view, convert them both into gray pictures. And then when they're converted to gray, you convert one image into red, the other image into a blue. So the right eye sees only the blue image, the red eye, the left eye sees only the red image, and those are complementary colors, and they make a nice gray. And in case you're interested in getting 3D equipment, a good place to start is at bearsin.com. Okay, now we're going to put 4 things together here: 3D, microscopy, focus stacking, and memory. This is why you want memory. You have a lot of specimens of one kind or another, and where in the heck are they stored? And you put something under a 3D microscope and you take a look at it, and the minute you move that thing away, it's gone. The only thing that remains is in your memory. But we'll have computer memory here so we can retrieve things. This is a picture of my setup, and I'll go through the picture on the left first. You notice this knob up here on the top, right in there, and behind it is this board. Let's see here. This board can be moved back and forth between this stop and that stop. The camera is mounted on that way, so if I take a picture here, I'm getting a left eye view. If I flop it over there, then I'm getting a picture of a right eye view. Now, direct your attention to the right one over here, the right picture. The camera itself is kind of a tubular looking thing, as some of it doesn't show up well right in here, but a tubular gadget like that. This wire runs off to a USB port. This rocking back and forth is pivoted around this point right in here. Okay, so what we want to do is to have our specimen located essentially right there. So, and the block can move up and down. This block has the camera on it, and I can move it up very far. You saw that picture of the gargoyle. It weighs about 5 pounds and barely fits on the platform down below. It certainly doesn't fit on the lab jack here. Now some details. I put in some slide guides so this would go up and down smoothly. And this is the coarse vertical clamp. So I can move it up someplace, clamp it in place.
Yeah.
Then the rack and pinion allows me to go up and down small distances. The focus knob on the microscope is located there at the top of that tube thing. And down at the bottom, I have a tip stabilizer, which is very important for close focus. There's a couple things about the design of the microscope as I got it that are really okay for how it was designed, but it's not good for my particular purpose. And then there's the pivot axis right in there. That's where we want to have our object. And that wire goes off to a USB port. So here's the Optitech microscope. And this point right in here can rotate. In other words, this top can go toward you or away from you. And it can also move in and out this way. And those are things, the motions that you don't want for doing really close focus, especially when you have to do the 3D. Also, this base over here is sort of held in place to keep from rotating by a plastic threaded screw. So in any case, what I did was I took this device, let's see here, I took this plinth right in here and I detached it and drilled through here and fastened this thing into that rocking back and forth board. Just fasten it in with a tight screw. You'll notice that this particular microscope has 1600 by 1200 pixels. I have used some 800 by 600 pixels, but those are a little bit harder to focus and they're harder to mount. I really like this guy. So anyway, the idea is you move this over to the left stop.
Excuse me, Cork. Could you give us an idea of the overall height of that instrument?
Yeah, about 18 inches to 2 feet.
Okay,
And the length of the microscope, I'd say, is 6 inches.
thanks.
Okay. So anyway, you take a picture of the left stop, you take a picture of the right stop, and there is your 2 pictures for the 3D. As I said, you want to get things centered, or you want to get whatever you're looking at the pivot axis so that you get the good 3D. So what I have here is what's called a lab jack. The upper part pivots on this nylon bushing, and you use this lab jack to move things up and down to position them along this line of the pivot axis. Okay. By the way, there's another thing called a lab jack, which is an electronic gadget that you can program to read voltages or something. This is a whole different thing. Call it the ancient kind. For simple 3D, rotate the microscope to the left stop, focus, take a picture, and it goes into memory. Rotate the microscope to the right stop, take a picture, and it goes into memory. And then to convert it into some good 3D, you use a program called Stereo Photomaker. It's very nice. It's free. It costs nothing. All you have to do is download it. And unlike lots of other things that you use for Windows. None of this goes into the fancy dancy stuff that keeps track of this, that, and everything and warns you that you got to have an update or anything like that. You just click on it and it works. It's really nice. The place to locate it is there, code cpac.co/download/stereo-photo-maker.html. And this is what you get on that screen. You can load it as a 32-bit or a 64-bit, the zip file. You go into the zip file and just drag the thing out, and now you've got a program that works. And that's a typical kind of a picture. That's a roly-poly bug. Okay. Whoops. Wait a minute. Something. Yeah. What the heck? Oh. Stereo Photo Maker 6.10. Okay. I wish I'd been born smart instead of good looking. Let me get back to where I am here. Okay. Back to this one. There is, well, let's see. I wanted to go back just before that. I wanted to do this picture. Okay, here is a gargoyle, which is actually a very gray thing. I took a picture with some just red paper in the background. And the next picture shows you the anaglyph of it. And I think you'll kind of like this thing. That's sitting somewhere over my desk, warning me to behave. Okay, now to get closer in, what we're going to do is the following steps. Instead of taking a picture, we're going to be taking a video at the left stop and a video at the right stop. Take a video at both stops and then use a process called helicon stacking. Now, Bob actually has some other focus stacking program, and I'm sure he'll tell you about it. I use Helicon simply because I started and it works. He's got something that he likes and it works. And then use Stereo Photo Maker. So now we'll go through kind of what the steps look like. This part here has to do with the focus stacking. Here's a close-up of call it a paw of a scorpion. And you can see that a little bit of it is in focus and all the rest is out of focus. There's very little depth of field. And this one is, I think, from a fly, and some of it's in focus and the rest is out. Now, focus stacking works like this. Place the object at the pivot axis, and you take pictures focusing at all of those different places along there. Now, there are two ways to do that. The way that I use is leaving the camera in place and adjusting the focus while the video is going on. But you can also do it by essentially moving the camera with the rack and pinion. And you have the software that finds the sharpest focus at all the points, combined into a composite image. You say, what? That's a whole lot of work. Well, that's what the Helicon thing does. And I got this program called Helicon Focus Lite, $115 for a lifetime license, and I just got my latest update today. So it's a pretty nice program. It's lifetime. They update it from time to time. So rather than take a whole bunch of pictures, boy, click, 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 you take a video. And when your screen comes up for the camera, you have a choice between taking a picture with this button right in here or taking a video with that thing right there. All you got to do is click that movie, click that to start the movie, click it to end it. But it takes 30 frames a second. So if you take, say, 3 seconds going through your picture, you wind up with 90 pictures. And you turn the focus knob while in the movie mode, or you can do a distance adjustment too, and then you hit the enter to stop. And when you do that, it goes into memory. Isn't that nice? Use the Helicon software or focus stacking software and put the thing into memory. And you do that for both orientations, so you have a focus stacked left image and a focus stacked right image. But this picture right here shows you how you can improve the depth of field by doing the focus stacking. And you can actually do better than that, but I didn't. And there again, you can see there's a lot more detail that you can see in here with the focus stack image. So there's an example of a side-by-side of a moth, a grain of table salt. That 700 there means 700 millionths of a millimeter. In other words, it's points, 700 millionths of a, I'm sorry. Let me just say it so I don't get myself confused. That's 0.7 millimeters. And there's the anaglyph, and you can see that grain of salt in 3D. Okay, so this camera, you can see, is capable of doing everything from very big to very small. Okay, those are the mouth parts of a fly, a lava rock from Santorini, and now it's show and tell time. Okay, now we'll show you the apparatus here. I'm going to start with showing a couple of viewers. One of them is this device right here. That's the home stereo viewer, and I have a side-by-side picture in it. This distance across here is 7 inches, and these squares are 3 inches. The imaging part of them is this gadget right here, which is a lens and a wedge. And if you look at it right there, you can see the triangular wedge part of it. That's what makes it visible at the distance that you see there. Another kind of viewer is this thing that you see the kids wear, and you put you just put a cell phone in this slot over here like that, and then you have these 2 lenses that can be moved back and forth a little bit. And they are the crummiest lenses I've ever seen, but there they are. Another kind of viewer is this gadget right here that is basically kind of miniature versions of those little plastic things. And this little device is good for looking at the same kind of 3-inch picture. Okay, so those are the viewers, and of course you know kind of what the colored glasses look like right here. I don't know why they're upside down. Okay, now I'm going to show you the 3, to see where I got to find this thing. Excuse me. Okay. This one right here, you can see, has the 4 mirrors. There's 1, 2, 3, 4, and you can move it just like this, just like that, to get the left and right views aligned. I bought this thing about 25 years ago. This little guy right in here is the same thing, but it's enclosed and you use this little knob on the top to adjust the angles of the mirrors. And here's another one of those 4 mirror devices, and you turn this knob here to adjust those. So there are numerous ways to see what you want to see. Now, I'll show you my little device right here. Okay, you can see, sort of judge things by the size of my head. You see how this whole thing moves back and forth. The camera on that mount, and I can move the camera, let's say, way up here, and it still moves back and forth through the same angle. Remember, it's the angle that matters. And then I can pull this thing way down here a lot closer, and I can position it like that. So the camera itself is here. This thing part right in here is the camera, and here is the adjusting knob, and this just goes off to a USB port. And if we go down a little bit lower, like this, you can see this part right over here is the axis about which this device rotates. You can see that. And then you have that. Is the lab jack. And by simply turning this screw, I can move things up and down. It's kind of about that easy. So anyway, what I'd like to do now is to switch cameras, and I'm going to just go through this process and show you kind of what we'll be doing. Okay, hang on here. I'm going to try restarting the camera app. I apologize for this, but this is just.
We need to go back to the old technology.
Yes.
Yeah, that would be really nice, wouldn't it? Ah, there we go. Fantastic. Where in the heck?
Didn't we all grow up with those Viewmasters?
Yeah, we did.
Eons ago.
Yeah.
Except who grew up?
By the way, the
lose.
Holmes viewer was invented by Oliver Wendell Holmes.
Wow.
Well, thanks for that. Well, okay. I'm just going to do something else here. I'm going to say, well, let's see. You can see that. Can you see that picture there with the? That's a tube.
Yes, yes, we do.
Okay. Now, what I would do.
No, I don't see it.
If I rock this thing back and forth like that, okay, you can see how the view changes.
Yes.
What I would do is start here, start the movie, go over to here, and end the movie. Then I would go over to here and essentially repeat the process, start the movie, do this,
There it goes.
end the movie. Okay? So that is how I get the left view and the right view.
With stacked focus.
What I'm now going to do, let me get things prepared here just a little bit. And I'm going to go to Helicon Focus and then show you how that part works. You notice I have kind of a blank screen that says drag images here. So what I'm going to do is to open a video, and I have some videos over here that I put in, and it looks like 2 of these things are a left and a right image. So I'll click on this one and say open. And it's important video. Now, over in this region right in here, you'll see that it says 82 pictures. You see that?
Yes.
Yeah.
Right there, it says 82 pictures. And I'm going to, well, let's see, I've got to get this thing a little, I want it over there. Down at the bottom here where it says render, I'm going to render it, and you watch what happens. That I've got to move this bunch of pictures back out of the way. Oh, come on, get over there and stay there. So it's going through all those pictures. You can see the progress down here in the lower left. It's going through all those pictures one at a time and finding all the sharp points in them. And when it gets done, there's the picture. If I go over to here and okay, now what I can do is give a name for that. And I'm going to say Rocky 1L. L for left. Okay. Now I've got that. And you'll notice that I've got good focus all the way from the background to the top. Get rid of the images. Just remove all images. And now I'm going to go to File, open the video. And now I'll choose this one. Open that. And it's again a bunch of pictures and it's ugly as sin. Hit the render button and it's going to go through there through all of those images. And I don't know how many there are. I'll check here. 86 images. And it's finding the sharp points in everything. Is it done rendering? It's not done rendering, I think. Okay, there it is. And I'm going to save that as Rocky 1. Whoops. R. I have no idea what kind of rock this thing was. Rock of Ages, maybe. Okay, now I'll get this out of get this app out of the way here. I'll just say stop share. Here we go. Now it works. Fortunately, just mess around and things happen. Okay, now what I did here was I hit the letter O, which opened. You're opening the left image. Then, since I labeled them something L and something R, it asks, is the R one the right image? And you say, well, yes, it's the right image. So now you see two images of this interesting looking rock, and it might not be in perfect registry. So what I'm going to do is to do an adjustment, which I use Alt-A. And what it does is that's an automatic adjustment to square things up. And it moved the horizontal position by a total of 8 pixels. And it changed the size by 0.2 degrees. Click out of that, and now you have a left and right image that you could see with the side-by-side. But what I have to do is hit F6, and on this computer, it's function F6, and it becomes an anaglyph. So there is your chance to look at an anaglyph, wow. And you very clearly see the 3 dimensions.
Oh, yeah.
Yeah.
Ain't that beautiful?
What are we doing?
Okay, now what I'm going to do is I'm going to stop that share, and share the Helicon focus again. And get rid of these pictures. Remove all images because I have something else in there to take a look at. So File, open a video, and I don't know what the heck this is. We'll see. Maybe it's another view of the same rock. I just don't know. Render it. It's going through there. That's a pretty large bunch of pictures that's being analyzed right there, because it's 216 pictures. That's 7 seconds worth of something. You can see it's as it goes through the pictures on the left, you can see that the point of focus is being changed time after time after time. And we're not quite halfway done yet. Boy, this one's got a lot of depth in it, it looks like. Okay, I'm going to save that thing as, I'm going to call it Rocky 2L. And yes, now what I'm going to do is remove all those images. Yes, and I'm going to open the next video, which was here. Taking a little bit to load that in. Well, you can see the big advantage of doing the focus stacking. With a good 3D microscope, you have more depth of field than you have with this electronic microscope, because the electronic microscope is full out at whatever depth you're looking at. But you still wind up, now notice these lines over here, right in there. Those things there are keeping track of data where all the sharp spots are. And you can be happy that you don't have to do all this work by hand. Again, I just chose a couple of pictures at here, a couple of old videos that I had made at random. And pretty soon we're going to have a good picture there. But you can see down here, we still have a little distance to go. But it's getting close. There we go. Now, this little red triangle down here says, well, Helicon got a little bit confused, but ask me how much I care. Okay. That was supposed to be a 2, but it isn't. Let's see here. Okay. And save that one. Now we'll go to the 3D software. I'll go back to the regular side-by-side view, which is F9. And what I'm going to do is just hit the letter O. Do I want to? I don't want to save that image, but I'll choose this left one.
We're still looking at the Helicon Focus software.
Oh, are you? Okay. Thanks for letting me know. Share the screen. Okay. Now what I did here was I loaded up those two pictures. The left image first, the right image, the one called L, the one called R. And you'll notice they look like they're a whole lot different size than everything else. But if I go up there to, if I do an Alt A, come on now, wants me to do something else with it. View, adjust, easy adjustment, auto alignment there. Now they came out the same size, and that's a left for a side-by-side view, and I'll show you what the anaglyph looks like. You can see there's quite a bit of depth in there. Y'all see that?
Yeah.
Okay, now I'm going to find something that to me would be a little bit more interesting. So sit tight just a minute here. Okay. Oh. Didn't really want to move those. Okay, I'll take this one, and move them up there. Okay. Now I'm going to go back to the Helicon. Go back to the Helicon, and now I'm going to remove all those images, and I'm going to open up another couple of videos. And I think you might like this one. Anybody recognize what that thing is?
Is that a horn coral?
Well, I was told it's a stromatolite from the east. STR1L, we'll call it that. Save it. Okay. And clear it out. Move all images, yes. And then I'm gonna open another video, which would be this one right here. Render it. This thing that's supposedly a stromatolite is about 3 inches across. Okay. Okay, stop the share. Share the screen of this one right here. This is back to the other the stereo photo maker. And what I'm going to do is go back to the side-by-side version of that. So we there. Okay. Now I'm going to open. I'm not going to save that. I'm going to open this one and It says, do you want to use R for the right? And the answer is yes. There's this stromatolite. I'm going to do an automatic adjustment on it. It moved it 1 whole pixel. And now I'm going to convert that into the anaglyph, and you can see the way it looks. And for the I'm going to do a color anaglyph. Okay, there's the color, there's the non-color. You don't see a whole lot of difference there. Okay, whoops. Well, maybe I had put the wrong button here. Ah, there it is. That's the color anaglyph. And it actually, well, it's a pretty colorless thing anyway. I'll go back to this one. And now I want to, I'll do one last one for you just for the fun of it. So I'm going to stop this share and share the screen on the Helicon Focus and remove all images. Yes, I'm going to show you a bee now. File, open a video. This one here. And I'm going to render it. Now this bee has got a lot of depth to it. And in case you're wondering what that red background is, well, it's Play-Doh. Okay, there it is. Save this thing. I'm going to call it, I'll just call it BL. Okay. File. Move all images. File. Open the video. And choose this one. This one winds up being a really nice picture when you're done. It's busy rendering it, as you can see down here at the bottom. It's beginning to look like a bee. Save this thing as BR. Whoops. BR. Okay. Stop that. Share. Start a share. Okay, now we have to get, well, all we got to do is just open another, hit the O button. Okay, I'm not going to save that. Open the left B and the right B. And there they are. And now what I'm going to do is automatic adjustment. And Jill just told me these are backward. And so I was kind of hoping that would show up. Jill can look at side-by-sides and see them very, very readily. But just for the fun of it, I'm going to make an anaglyph out of it the way it is. And if you look at that thing, you see that is Berserk. Okay, remove the anaglyph part, go back to F9 and stereo. Let's see here, adjust there's a way to do this thing. Okay, swap left, right. There we go. And now if I do the anaglyph,
So there he is.
there it is, the way it's
Yeah.
supposed to be.
Yeah.
Now there is one more thing that I want to talk about here, and I'll show you what it is, just kind of in principle. What you really like to do is to sort of pay attention to the closest thing to you, and you can. If I do, it's called Control A, which is a manual adjustment. I can put the crosshairs right here, click on this one, and click on this one. And then when I do the anaglyph, it will show up with that particular part of the wing sort of really close to you. If, on the other hand, you focus on something that's far away, like this part, well, let's see here. Yeah, I'll take this foot right down here at the bottom, and this foot right here at the bottom, and I'll do the anaglyph for you. And what you look at now is that the whole bee looks like he's standing up.
Mm-hmm.
Oh, yeah.
You notice how he looks just a whole lot closer to you than he did before. It's like the stuff in the background is a plane, and he's way above the plane. If you notice those videos that Bob was showing, sometimes things were coming out way out of the screen. Well, that's kind of how they do it. So that's the technique that you want to see. And I think I have an example where I can show you that, and then we'll call it a night. No. Okay. Screen sharing. Share the screen, and let's see if I can find.
That last thing you did was setting the window.
Yes. Yeah, it sets the window. Okay. I'm going to share this one. So this is another picture of the bee, and it's a glyph, an anaglyph, and if I switch over here to that one, you see that wing is sticking way up.
Mm-hmm.
That wing, the right-hand wing, is sticking way up out of the plane,
Mm-hmm.
and I do it here, and it doesn't. The tip of the wing is at the kind of window that you're looking into. See how it moves?
Yep.
Yes.
And all of that can be done by using Control A, which is a manual adjustment. So you just pick on some spot that's in the foreground or some spot that's in the background, and use that as your reference point. So that's pretty much what I have to show y'all. It is not difficult really to make up that device that I've got. It's nice if you have things like a router to do it with, but who knows? Maybe you don't have a router in your garage. So there you have it. Let's see, share the screen. There it is. Any questions that you have?
So what was the total cost of all your hardware?
Well, the little camera was about well, it was $79 when I bought it. I think they're more or less time and a half or twice that now. I don't know. The all the wood that I used was just scrap wood out of my ordinary supply. I think I got the lab jack for something like $20, and I use a photographic gray card for the for a background for a lot of things. The rack and pinion thing, that's really part of the camera that I bought. Bought that as a unit. And I've got these lights. I've got some LED lights that I use for illuminating things, but you just be a little bit creative. Just use whatever lights you have around. You don't particularly want to use the light that's in the camera, because let's say you're looking at something with your two eyes. You don't change the light simply because you're looking at it with your left eye and then you're looking at it with your right eye. You have the same lighting, the same lighting angles and so forth for both pictures. But if you use the light that's in the camera and then you move the camera, then you're changing the orientation of the direction of the lighting, and that can be a little confusing. I have done it with an electron microscope and it seemed to work. And with this particular camera, I will sometimes use just a little bit of light if I'm looking into some kind of a dark place. So, but normally you don't particularly want to do that. Let's see.
Is there a difference between what a stereo camera takes in 3D that what you're doing?
Yeah, I have a stereo camera and I found out how you can get one. You know what you do? You turn 79 and your wife gives you one for your birthday.
Yeah, Amazon.com.
Okay. Anyway, yeah, the difference is that with the stereo camera, you've got the two eyes at a fixed distance apart. Now, that doesn't mean a constant angle. It means a different angle if things are 10 feet away or if they're 2 feet away, you see? And so this business of tipping the camera so that you can always have the same angle, that's a big advantage. With my stereo camera, if I take a picture of you from, let's say, a foot away, you won't like the picture. But if I put your head, no, I'm not going to do that. But if I take a picture of you with a regular camera and then I turn over a little bit looking so that I'm moving at something like 5 degrees or something like that, then you'd like the picture.
So the 5 degrees.
And the stereo camera is not any good for looking at things really close. It just isn't.
Okay, thanks.
Any more? Do we have people still watching?
Yeah. Can you hear me?
Yeah.
That was really quite excellent, Cork. Thank you very much.
Well, it's my pleasure. I've been having fun with this. And by the way, I actually wrote up a blurb on this, which is a PDF, and I don't know if Bob's got a copy, but I will send him, and he can distribute it at will.
Back in the 50s, they also had a macro stereo camera with the lenses close together.
Oh, really?
And in one of your things, Bob, that showed a NIMSLO, which has 4 lenses on it for doing lenticular primarily, but it produces 4 images. If you take the 2 center images, the two that are close together and put a macro lens, a plus diopter over those two lenses, you can take macro pairs with that.
And then how do you present them?
How do you develop the film?
No. It's a you print it. You have two prints, and then you size those the same as if they were a normal pair. Only it'll be macro.
But you look at it through a viewer?
Yeah, with a viewer. Yeah.
Cool. That would be fun to do with some of Karen's rhodochrosites from Sweet Home Mine.
Mm-hmm.
Well, you know, if you do a rhodochrosite and you look at it side by side, it'll be absolutely beautiful.
Yep.
If you make it into a gray anaglyph, you lose all that beautiful color. And if you make it a colored anaglyph, then it gets a little bit crazy because
Because of the red?
the gem is about the same as the color of what you see with your red lens. And it would be a terrible picture.
Well, would the same apply to blue colored minerals then too?
Probably.
Yeah.
I haven't played with the blue stuff yet, but I'm quite sure that would be the case.
I made stereo pairs inside the Sweet Home Mine of the rhodochrosite still in the pockets.
I'm looking forward to that program, Chauncey.
We'll do it someday when we get back together.
Yeah, really? That'd be great.
On slide projector. In color.
Yeah. Just by the way, one of the things I didn't mention is that they have these 3D TVs now. And the way they work is that they have polarization, and they send some kind of a radio RF signal or something like that. And you look at it with some kind of glasses that alternately turn off and turn on left and right eyes. So your one eye gets blocked and you see with the other eye, and then the other eye gets blocked to see with the first eye, the left and right views. And I think it drives some people kind of crazy because they don't really like the flicker. Or maybe they respond to the flicker and it makes them kind of bad. Maybe they could make a movie called My Friend Flicker.
Flicker, good one. We're old enough to get that.
Yeah.
Well, any other questions for
That
Court?
finally came in focus.
Oh, well, yeah, it's just been sitting there.
Yeah.
I can
now
move
it's
it in
finally
and out of
focus.
focus.
Here
I
it
have
comes. There's
here
the
a trilobite. We'll put it in like this. Cute little trilobite.
Mhm.
I can do a 3D of that too. But I actually have a lot more nasty little bugs and gnarly teeth and that kind of stuff than I have good gemstones.
All right. Well, good night, guys.
You've got gemstones. All right.
Gemstones neat.
Well, let's call it an evening, Cork. Thank you so much for your contribution. This has been really very entertaining and excellent. Thank you.
Well, George, I had fun. So thanks for having me.
Thank
Glad
you.
you feel you've been had.
All right.
Okay. We'll see you again sometime.
Well,
Next
thank
week.
you
Thank
so
you,
much.
Kelly.
Ooh, cool.
Isn't that cool? There's the snelling.
We're here.
Your microphone says? Oh.
Hey, Bob, are you going to be able to capture a screenshot of the grid with everybody with their red and blue glasses on?
I think Bob can do
Yeah,
that.
you're asking the wrong person to do something like that.
No, Bob Johnson.
I'm not sure in Zoom. I
Where's
can only
Carly?
see a few people at a time.
Carlene, get your glasses on.
Yeah, Bob Johnson, Bob, if you keep going through the view options, I've managed to see
Where are
grid
your
with
glasses?
most of the people
Here,
on
sit right
it,
here.
and then the screenshot on one side.
Anything to,
Ah,
Put
I
your,
haven't seen me on there at
Thanks,
all.
Deb.
no, I haven't seen you, so just sit here.
No, I'm not sitting here.
Sit here and
oh,
watch it.
that's better. Thank you, Debbie.
On in there. I don't know how to get on the top.
Did you do here? Let me show you. You have to share, do video down here in the left corner. Here, right here. See where it says stop video?
Yeah.
But if you click it, if I click it, it'll stop video. But if you,
then it'll come on.
yeah,
Okay.
okay. Oh, that's so cool. Who else is here? Where did Vince go?
Yeah, great
Vince still with us?
I muted a lot of people. They'll have to unmute themselves to talk.
Oh, look at that.
Righto.
Yes, Beth, I'm still here.
Oh,
Cactus.
oh, look at that. That's a prickly pear thing.
Oh.
Hi, Steve. Raise your hand if you can hear me. Okay.
Great technology.
I hate it.
That looks like copper. Is that copper?
Oh, is this all in black and white?
There,
Some of them.
Carlene's got her glasses on now.
Yeah, apparently it's copperboard.
Oh, that's nice. Isn't that cute? There's a seashell. Oh, no, that's your drill. That's your drill. Oh, look at that. That's a cork picture if I ever saw one.
Oh.
Okay, we'll give the people a couple more minutes. Can you hear me, Bob?
I hear you.
Oh, look at the cemetery.
Anybody hear me?
Yes.
And a telescope. And a wheel. And a horse. He needs some food. Some cows. A hike. Like up, that's us.
Oh,
That was our FSS meeting.
A mask.
Yeah. Uh-oh, there's a dead person.
I mean,
Ancient Egypt, guys. An ancient Egyptian mask and a mummy.
Oh, look at the eyeball on that flower.
Wow.
that's one compound
Oh, look
eye.
at that.
Gargoyle.
Oh, there's the geese. I know that piece. Jill should be wearing that piece.
What is that?
This is a mineral of some sort.
Yeah.
Oh, that's so cool.
Good 3D.
Okay, we'll give people a minute more.
Here's your glasses.
Is this the first Zoom meeting?
Yes, before it was all WebEx.
Oh, what?
WebEx.
Oh, you can hear me now. Okay, someone can hear me. I just got the right button for that.
Meteorite?
No, that's basalt bearing olivine.
That looks like a fossil bird hole. Is that what it was, Bob?
Yeah.
Oh. Okay.
Oh, look at that. Ooh, look at that. Okay, it's 7:05.
Yep.
So I think we can call a meeting, have George call the meeting to order.
All right.
Oh, look at the ring. There's one for the Snellings. Oh, look at that. I bet Jill's wearing that.
Okay, it's a piece of overraytite.
Oh, look at that.
Mothra.
Yeah.
That's not a flying bug, it's a dead bug.
No wonder you can't sneak up on a fly.
Whose fire tablet? I can't see for the light behind you.
Let's see. That better?
Let's see. Now you're totally dark.
Oh. Well, you're not missing anything.
This is Debbie. Can I ask a question just because is there going to be a meeting or are we just, I'm not
Yes.
sure.
Yeah, we're going to have a meeting here as soon as people get organized.
Okay.
Well, why don't we pause?
30 minutes.
Can you hear me?
Yes.
Okay, why don't we pause the slides for a moment? We'll do our business meeting and then we'll come back.